exploring the depths of a gas giant. Jupiter.
Jupiter, also known as the gas giant, is a colossal titan in our solar system that has fascinated researchers for thousands of years. For a long time, scientists have made assumptions about the composition of Jupiter's core. They suggested that heavy materials like metal or rock, or perhaps unusual forms of matter under tremendous pressure, might make up the structure. However, recent simulations and observations have shown that there may be a surprising reality to what we previously thought about Jupiter's core. Recent studies suggest that Jupiter's core may not be as solid and compact as previously thought. Alternatively, it could be a diffuse, hazy area where gas progressively becomes denser. This theory raises new questions and creates new possibilities for our understanding of planetary cores.
To form a gas giant, it's simply about having a large enough core to have enough gravity to start grabbing gas and holding on to it. And that's it.
All of a sudden, things are falling in an almost uncontrolled way, a runaway gas secreting. And that's how you build a giant planet.
Planets like Jupiter are known as gas giants to distinguish them from smaller, rocky planets like Earth and Mars, which are referred to as terrestrial planets because they have solid surfaces. Gas giants are distinguished by their enormous size, gaseous makeup, and lack of a solid surface. It is essential to remember that the planet's primary composition determines whether it is classified as a gas giant. Although Jupiter has a core, its composition is still not entirely known, despite being mostly made of gas. Hydrogen and helium gases make up the majority of Jupiter's composition, hence the reason it is classified as a gas giant. Unlike terrestrial planets like Earth, which have solid surfaces, gas giants are primarily gaseous planets with no clearly defined solid surfaces. Around 75% of Jupiter's composition is hydrogen, which makes up the vast majority of its mass. The remaining mass is mainly helium, along with trace amounts of methane, ammonia, and water vapor. The gases inside Jupiter are compressed by the enormous gravitational forces caused by its enormous size and mass.
Jupiter's environment is one of the most vicious in the solar system, and that's because of its incredibly strong magnetic field.
As we travel deeper into the planet, the pressure and temperature increase, transforming the gases into new, strange states. Near the center, hydrogen transforms into a metallic state exhibiting characteristics of both a metal and a gas.
We know our protoplanetary disk only survived for about 4 or 5 million years. So we know that Jupiter was finished forming only 5 million years into solar system history. And that means we have to really jumpstart that process and get Jupiter to build a really big rocky core really, really fast.
We think that the core material that might have been there is actually dissolved and mixed in with the rest of the planet.
The core of Jupiter is a mysterious place that is considered to be under extreme pressure and temperature. Despite not knowing much about it, scientists have come up with several theories based on simulations and observations. One of the most widely accepted theories suggests that the core of Jupiter is made up of heavy components, such as rock and metal. As Jupiter was forming and gathering material from the early solar nebula, these components would have been drawn towards its center. However, the exact structure and composition of the core remains unknown. The extreme conditions within the core of Jupiter give rise to remarkable events. For instance, hydrogen gas is compressed into a state known as metallic hydrogen under high pressure, which has both gas-like and metallic properties. It is believed that a layer of metallic hydrogen envelopes the planet's core and extends outward. Additionally, Jupiter's strong magnetic field is thought to be created and sustained primarily by the core.
It's a very large feature in our solar system. It's a pity we can't see it.
So a planet that has a magnetic field has a magnetosphere when its sphere of influence extends beyond the planet out into space and affects the region around it. The magnetosphere of Jupiter is vast. So if you think of Jupiter being 10 times the size of the Earth, and the magnetosphere is 100 times the size of Jupiter. So this is vast, a big, big, big volume.
The planet's massive and dynamic magnetosphere is shaped by charged particles from the Sun interacting with the metallic hydrogen surrounding the core. This process is probably responsible for the formation of the planet's magnetosphere. More studies and investigations are needed to unravel the mysteries surrounding Jupiter's core. Scientists are particularly interested in researching the core to gain insights into the formation and evolution of gas giants in our solar system and beyond. With the help of future missions and technological advancements, more direct observations and data could improve our understanding of the core. The core of Jupiter is a fascinating and enigmatic place where strange states of matter and harsh conditions coexist.
None of our models of the interior of Jupiter turned out to be correct. That means we have to go back to the drawing board.
What Juno found was this amorphous mass, a fuzzy thing in the center of Jupiter. It's not as solid as we expected if it were just a metal and rock core, but there is something there.
Despite the many questions that remain unanswered, ongoing research and upcoming expeditions may reveal the secrets hidden within this extraordinary gas giant.
The Great Red Spot. The Great Red Spot has been on the surface of Jupiter for at least 300 years. It was first observed by Gian Domenico Cassini 3 centuries ago. And he noticed that it seemed to be a big storm on the surface. It's 3 Earth diameters wide. And it hasn't moved. It hasn't gone north or south in all that time. But we really don't know how deep it goes. Is it a thin feature like a piece of paper? Or is it a great big angry wedge of storm that penetrates deep into Jupiter all the way to its core or whatever inside? We don't know.
Astronomers have long been fascinated by Jupiter's Great Red Spot, a massive and swirling storm in the planet's southern hemisphere. The storm is oval-shaped and has a reddish-brown color, which can change over time. It is the largest storm on record for our planet, with a diameter of around 1.3 times that of Earth. What makes the Great Red Spot unique is its exceptional lifespan. It has been seen for at least 400 years, making it one of the solar system's longest-lasting storms. However, historical observations suggest that the storm's size and shape have likely evolved over time. We still don't fully understand what causes the Great Red Spot to persist, but we do know that its rotation in Jupiter's southern hemisphere is anti-clockwise, making it an anticyclonic storm. The storm's dynamics are influenced by Jupiter's quick rotation, which takes less than 10 hours to complete one full cycle. The reddish color of the Great Red Spot is thought to be caused by complex organic compounds and chemical reactions in Jupiter's atmosphere. Although study on the storm's precise composition is still ongoing, gases including ammonia, methane, and potentially water vapor are thought to be present. The Great Red Spot is a dynamic feature that has undergone size and shape changes over time. Its size has fluctuated with phases of expansion and shrinkage, as recorded by astronomers. The storm appears to be getting smaller and has lost some of its color in recent years. Several spacecraft missions, including Voyager, Galileo, and Juno, have yielded useful information and insights into the Great Red Spot. For instance, information from the Juno spacecraft's arrival in 2016 has helped scientists better understand the storm's interior structure and profound roots. The Great Red Spot highlights the dynamic and enigmatic character of our solar system and continues to captivate scientists and amateur astronomers alike. Future missions and ongoing research will surely shed more light on this fascinating storm and its function in Jupiter's atmospheric dynamics. A team of scientists embarked on an expedition to explore the depths of Jupiter's core, where they encountered unimaginable temperatures and pressures. In this magnificent planet, metallic hydrogen and heavy elements merge to form the very fabric of its core. Through non-stop work, the scientists uncovered the mysteries of Jupiter's core, including the complex network of forces that shape its atmosphere, propel its magnetic field, and influence its future. The location is a place where the limits of our understanding are stretched beyond comprehension and the rules of physics are tested to the breaking point.
But wait a second, like you've seen that thing on Jupiter, that storm that never quits? The big red thing, the big...
Yeah, we call it the red spot on Jupiter, we call it Jupiter's red spot.
Okay.
Yeah. Because that's how we roll.
That thing is...
Spots on the sun, sunspots. See? See how... So what is Jupiter? It's 100 times bigger than Earth. More than that, 10, 1,000 times bigger than Earth. It's like, it's 10 times across, cubed. So it's 1,000 times bigger than Earth. It's mostly gas. And it rotates once in about 10 hours. You want to talk about ferocious Coriolis forces? We have storms that last weeks here. Hurricanes that pick up and they get... Weeks on this little speck we call Earth that has this much atmosphere on it. Go to a planet that rotates twice as fast, is 10 times as wide, 1,000 times the volume, and is mostly gas, and you're complaining that it lasted 300 years?
You are really good.
The discoveries that lie ahead keep us motivated as we continue our exploration of Jupiter's core, providing us with a greater understanding of the universe's beauty and complexity. With every new discovery, we are reminded of the countless wonders that lie ahead, inspiring us to keep learning and to stretch the limits of human exploration. Pursuing knowledge not only allows us to learn the secrets of a distant planet, but also uncovers the wonder and majesty of the universe itself, expanding our perspectives and igniting an eternal candle of human curiosity. That's it for today's video. Thanks for watching. For more videos like this one, be sure to subscribe and hit the like button. We'd also love to know your thoughts in the comments below. We'll see you in the next video.